This is Geometry, Lesson 3.3, Proving Lines Parallel. We're going to determine today whether two lines are parallel. So actually, this first kind of chunk with all the blanks in your notes, we're going to come back to that in a little bit, and we're going to jump into today's concepts. We're going to use this as a review. So about halfway down the page, it talks about the converse of the corresponding angles postulate. So the converse of the corresponding angles postulate says, basically, if you have corresponding angles that are congruent, then you have lines that are parallel. So that's your blank you got to fill in. It's pretty handy. It lets us come up with a bunch of different relationships. I typically abbreviate this as converse of CAP, corresponding angles postulate. So basically we can go from all those relationships we've been looking at, corresponding angles and such, and say that, well, if they have that relationship that I want, then my lines are parallel. And so here, we're actually going to maybe use that. It says which lines are parallel if angle 1 is congruent to angle 2, justify. So here we have angle 1 and here we have angle 2. And so there's a lot of lines in that picture, so I find it helpful to trace the lines that make the angles. So I can see that angle 1 is made by line A and M, and line 2 is made by line M and line B. And so what I'm looking for then is the lines that don't go through both of them, lines like A and B. Because those corresponding angles are congruent, what they told us right here, then I can say that these lines that go through them, A and B, are parallel. The justification for that, because yes, it does say to justify your answer, is to talk about, well, that the postulate we just did, converse of the corresponding, says if the corresponding are congruent, the lines are parallel. So that's what we're going to use, converse of CAP. Okay, and so we're going to repeat the process again for the next two. You can pause the video and try those ones on your own. Alright, so I did my tracing of the lines and the angles in blue this time. I saw that L and M are the individual lines that go through the angles. B goes through both, so B is the transversal. And then I said, well then L must be parallel to M. And I looked at 6 and 7 and said, oh, those are corresponding angles. So I used the converse of the corresponding angles postulate. Now, if you think about it, we had 4 theorems yesterday in postulates. We did corresponding angle, and then we talked about alternate interior, alternate exterior, and same side interior. Well, those all have converses as well. So the converse of the alternate interior angle theorem, I write that as converse AIAT, says that if alternate interior are congruent, your lines are parallel, which is pretty handy. Same side interior says a very similar thing. Converse the same side interior says if your same side interior are supplementary, your lines are parallel. I abbreviate this one, follow that same pattern, converse of SSIAT. Then the last theorem, if two lines in a transversal form alternate exteriors that are congruent, your lines are parallel. I abbreviate that one as converse of AEAT. All right, so we're going to start off using these in some proofs. We're actually going to prove 2 of them to be true. And as we do that, we're going to talk about a new kind of proof called a flow proof. So a flow proof, rather than having your 2 columns or a bunch of sentences, we're going to use boxes and arrows. And so we're going to use arrows to show those logical connections we're making. And we're going to set it up a little bit differently. We're going to write the statement with the reason right below it instead of next to it. So here's what we're going to start off proving, the converse of the alternate interior angle theorem. So when I do a flow proof, I think about what do I know, what do I need to know, and what am I proving? So what do I know? Well, I know the given is true, so I start with that. Angle 4 is congruent to angle 6 because of given. And I put it all in a box. And then I go look at the picture and I see, is there anything else that I know? Well, I've got the marks from 4 and 6, and then I look at 4 and 2. Now they put 2 in there, which means I probably want to use it. And actually, angle 4 is going to be congruent to angle 2 because they're vertical angles, so I can use the vertical angle theorem. A lot of kids try to jump to talking about 2 and 6. You can't yet, okay? You got to wait on that because you don't know anything about that yet. Because we don't have parallel lines. I've got 4 the same as 6 and 4 the same as 2. Whenever you see something that is repeated, like that 4 is, you can skip it by connecting the other pieces. So that's what I need. This is where I make my connections, the things that I need to prove it. I say, well, now angle 6 is congruent to angle 2. And my being able to connect stuff and skip the middleman, that's my transitive property of congruence. Well, then I think about, oh, 2 and 6. And I think about the fact that those are corresponding. And that we started off today talking about the converse of the corresponding angles postulate. It says if the corresponding are congruent, which they are, then these lines are parallel. So I say, oh, well, L must be parallel to M by the converse of the corresponding angles postulate. So that's kind of how we set up a flow proof. I like it. I think it's a good way to think about how you go through. You can see this is what we knew from the picture over here on the left. In the middle is what the connections we made, and then in the proof we made some more connections and conclusions. So we're going to do another one like it. All right, this time we're going to write a flow proof to prove the alternate exterior angle theorem, the converse of it. So we start with our given, angle 1 is congruent to angle 7 because of given. Put that in a box. We're trying to prove that L and M are parallel, so we got 1 and 7. So then we got to make some relationships that we see. If I just focus on that 1, I want to relate it to anything else in that group of 4 angles that it's in. Well, I look at 1 and 3, and I know those are congruent by the vertical angle theorem, so I connect them into a box. Well, then I just notice I repeated the 1. If I repeat the 1, then maybe I should connect the 7 and the 3. Same way we did before, transitive property. And then I think about the 7 and the 3, and I go, oh, 7 and 3 are corresponding. My converse of corresponding says if they're congruent, which they are, I just said that, the lines are parallel. So I go, oh, L is parallel to M. Converse of corresponding angles postulate. Now this one is an interesting proof because this isn't the only route we could take. So I'm going to write some stuff up in blue here now. It's a different route we can take on this proof. So I focus on the 1 and the 3, but if I look down at 7, I can see 7 is related to 5. And I can say, oh, angle 7 is congruent to angle 5 because they're vertical angles by the vertical angle theorem. And then I think about, well, 7 and 5, and I started with a 1 and 7. I repeated the 7, so maybe I should talk about 1 and 5. Think about 1 and 5. They are congruent because I repeated the 7. That's my transitive property. Well, then I look at that 1 and 5, and I can see they're both top lefts of those intersection, which means they're corresponding. So the converse of the corresponding angles postulate would say L is parallel to M. Same conclusion that we were able to come to before. We just took a different route to get there. You could even do something with 6. You'd have to do some supplementary relationships, which would actually take a little bit more time and a little bit more space. Okay? So we're actually going to jump back to the beginning of the notes where all those blanks were, and we're going to fill them in now. So lesson 3.2 was all about showing angles congruent and supplementary. To go congruent, we use the corresponding angles postulate, the alternate interior angle theorem, and the alternate exterior angle theorem. To show angles are supplementary, we use the same side interior angle theorem. Well, we just talked about all 4 of these, but we talked about their converses. And what their converses do is they show that we have parallel lines. And so we can use any of those 4 depending on what we have marked in the picture. Converse of the corresponding angles postulate, converse of the alternate interior angle theorem, converse of the alternate exterior angle, or converse of the same side interior angle. Any of those will prove that your lines are parallel. Okay? So before we had to use parallel lines to find congruent and supplementary relationships, now we've been turning it around. We've been using the converses to figure out if those lines in fact were parallel. So that's what we've done so far today. We've proved 2 of these theorems work, and now we're just going to use them in some example problems. So like I said, we have 4 different ways to determine if 2 lines are parallel. There's 4 different converses. So here it says, the fence gate at the right is made up of pieces of wood arranged in various directions. Suppose angle 1 is congruent to 2. So suppose 1 and 2 are the same, and if it's a good fence, they should be. It says our lines R and S parallel, explain. Well, I think about where 1 and 2 are located. I see that they're both outside those lines, R and S, and they're both on alternate sides of that other line that isn't named. That would tell me that they're alternate exterior angles. And today, we've been talking about that theorem, the converse of it. Well, the converse of the alternate exterior angle theorem would say, hey, if they're congruent, the lines are parallel. These are congruent. I was told that right here. So are the lines parallel? Yes. Our explanation then is that converse we just discussed. So really what you got to look for is that angle relationship. Can you find it? If you can, then you can talk about parallel lines. There's another way you could prove that R and S are parallel. It's using this angle 3 in the picture. So I start with knowing that 1 and 2 are congruent, maybe. And then I think about, well, 2 and 3. Those are vertical angles. So I could say, well, angle 2 is congruent to angle 3 by the vertical angle theorem. Our first one was given. We're doing a little mini proof here. Well, I think about, well, 1 is congruent to 2, and 2 is congruent to 3. I can skip 2 and say 1 is congruent to 3. Something that allows you to skip and connect statements, that's your transitive property. Well, if 1 is congruent to 3, you've got 1 here, I've got 3. Those are corresponding angles, and they're congruent, which means R would have to be parallel to S by that converse we've been talking about today of their relationship, corresponding angles, postulate. Okay, so I reasoned through that. That's my justification for another way to prove that R and S are indeed parallel. We're just going to finish off the notes with some algebra problems based off these concepts. It says, what is the value of x for which A is parallel to B? We want to look at that picture with those angles. I've got 111 down here and 2x plus 9 up there. You want to think about, okay, what kind of angles are those? Well, I see they're both inside A and B, so they would be interior. And they're on the same side, not alternate, so they're same side interior angles. And same side interior angles, starts with an S, are supplementary. So I know that together those two should make 180. So I can take their angle measures, add them up, the two angles, set it equal to 180, and solve for x. So that's what I'm going to do. I'm going to take my equation, start solving it by combining my like terms. I'm going to balance it and move that 120 over. I've got 180 minus 120, coming out to 60. I'm going to divide both sides by 2 to get x alone, and I get x is equal to 30. What that answer means in this case, because the question is what's the value of x for which the lines are parallel, is that if x is 30 degrees, this angle right here will be supplementary with that angle. Meaning I could use the converse to say the lines are parallel. But if for some reason x isn't 30, say x was 40, that angle up there would be 2 times 40, 80, plus 9, 89 degrees, and 89 with 111 makes 200 degrees. So those wouldn't be supplementary, meaning those lines would not be parallel. So 30 is the only value x can be to make those angles supplementary, to make those lines parallel. So you're going to try this next one, see if you can set up that equation on your own. You're looking for what is the angle relationship, and then you want to decide, are they congruent or are they supplementary? Because those are the two kinds we've really talked about. So pause the video now and then get your equation set up. All right, real quick, you can check your stuff with mine. I said those were corresponding angles, and corresponding angles we want to be congruent. So we would say 55 equals 3w minus 2. Pause the video, finish solving. And we should end up with w being equal to 19. All right, so that was determining whether two lines are parallel. Geometry lesson 3-3.